We live in a world where sending a message across the planet, streaming a movie, or making a video call happens almost instantly. But how does this invisible magic actually work? What powers the global internet behind the scenes? At the heart of it all lies a massive and complex system made up of network cables, routers, data centers, undersea infrastructure, and satellites, all working together to move billions of bits of data every second. This system begins with something surprisingly simple: a network cable in your wall. From there, your data journeys through local routers, travels across fiber optic backbones, dives under oceans through submarine cables, or sometimes bounces off satellites in orbit. Eventually, it reaches servers in data centers, the hidden computers that run websites, apps, and services. Understanding this process means uncovering how your devices talk, how data moves, and how the world is interconnected in real time. In this exploration, we'll dive deep into what network cables are and how they transmit data, how local connections power your home and office internet, how the world is physically wired together through undersea cables and satellites, how massive data centers and routing systems deliver content to your screen, and how technologies like DNS and IP addresses manage this global traffic. By the end, you'll have a clear, vivid picture of how this digital ecosystem works, not just technically, but visually and conceptually, from your fingertips to the farthest server on Earth. Here is a deep, detailed explanation of how network cables work and how internet connectivity functions across the world, with layered structure and clarity for deep understanding. We'll follow this path. Summary of topics that we are going to explore today. 1. What are network cables? 2. How do network cables transmit data? 3. Types of network cables: copper versus fiber. 4. How devices connect using cables in a local network. 5. How the internet connects the world. 6. Submarine cables, the backbone of global connectivity. 7. Satellite internet, the sky path for data. 8. Data centers, servers, the brains of the internet. 9. Routers, IP addresses, DNS, the traffic management system. 10. Summary analogy, the postal system of the digital world. 1. What are network cables? Why do we need network cables? Network cables are the physical wires used to carry data between electronic devices. Imagine them as digital bridges. They link computers, routers, switches, and servers in a way that lets them talk to each other. How are they constructed? Inside a typical network cable, e.g. Cat6, you'll find 4 pairs of copper wires twisted together. Twisting reduces interference and noise, like tuning a radio to prevent static. The outer jacket protects the internal wires from physical damage, moisture, and electromagnetic signals. What role do they play in networking? They create local area networks, LANs, the small-scale part of the internet, like your home or office. Without cables, or Wi-Fi, devices couldn't send or receive data from each other or the internet. 2. How do network cables transmit data? What is being transmitted? Data is just zeros and ones, also called binary. Every photo, email, song, or video is converted into a stream of binary data. How does this binary data travel through cables? In copper cables, these zeros and ones are sent as electrical pulses. A high voltage might represent a 1, and low or no voltage, a 0. These pulses travel extremely fast, nearly at the speed of light, through copper. In fiber optic cables, the data is transmitted using light pulses. A laser or LED blinks in precise patterns, where light on might represent 1 and light off a 0. These pulses reflect and refract inside the cable's glass core, a process called total internal reflection, allowing them to travel hundreds of kilometers with very little signal loss. How does a computer understand this? Your computer's network card, NIC, acts like a translator. It converts digital instructions into electric light signals when sending, and reverses the process when receiving. 3. Types of network cables: copper versus fiber. Copper cables, Ethernet. Types: Cat5e, Cat6, Cat7. Transmission, electric signals. Max distance, 100 meters before signal degradation. Speed, up to 10 gigabits per second. Cat6e. Advantages: cheap, flexible, easy to install. Limitations: vulnerable to electromagnetic interference, EMI, less effective over long distances. Transmission, light pulses. Max distance, tens to hundreds of kilometers without amplifiers. Speed, 1 gigabit per second to multiple TVPs, terabits per second. Advantages: high speed, immune to EMI, secure. Limitations: more expensive, delicate, requires careful installation. Fiber is used for backbone connections in cities, between countries, and within data centers, while copper is common inside buildings. 4. How devices connect using cables in a local network. What is a local network? A local area network, LAN, is a group of devices, PCs, printers, cameras, phones, connected within a limited area like a house or office. How are devices physically connected? 1. A router is the central hub that connects to the internet. 2. Ethernet cables run from the router to devices or to network switches, which expand the number of available ports. 3. Devices use their network interface card, NIC, to plug into the Ethernet cable. 4. Once connected, data packets travel back and forth between devices at high speed for file sharing, gaming, or accessing the internet. Why use cables over Wi-Fi? Wired connections are more stable, secure, and faster, especially for things like gaming, video streaming, or transferring large files. 5. How the Internet connects the world. What is the Internet? The Internet is a vast system of interconnected networks. Millions of private, public, academic, business, and government networks linked globally. What happens when you visit a website? 1. Your request, e.g., openyoutube.com, is converted into a data packet. 2. That packet is sent to your ISP via router modem. 3. The ISP routes it through regional, national, or international networks. 4. It eventually reaches Google's data center, or wherever the website lives. 5. The server responds with the data, video, text, images, which is sent back the same way. It all happens in milliseconds. How is all this data transported? Primarily through undersea cables, fiber optic backbones, satellites, and wireless links that form the physical infrastructure of the Internet. 6. Submarine cables, the backbone of global connectivity. What are submarine cables? These are massive fiber optic cables laid on the ocean floor, connecting continents. Why are they used instead of satellites? Submarine cables offer faster speeds, low latency, higher capacity, can carry terabits per second, reliability, less weather disruption. How are they built and protected? A core glass fiber carries the data. Layers of insulation, steel wire, and waterproofing wrap around it. Ships lay the cable along carefully mapped paths that avoid tectonic plates or fishing areas. Repeaters, signal boosters, are placed every 50,100 kilometers. Examples: faster cable, by Google, 60 terabits per second between US and Japan. Maria, Microsoft Facebook, 160 terabits per second between US and Spain. 7. Satellite Internet, the sky path for data. What is satellite internet? Instead of cables, data travels via radio waves to satellites in orbit. Types: geostationary, GEO, 35,786 kilometers above Earth. High latency, 600 milliseconds. Low Earth orbit, LEO, 5,002,000 kilometers altitude. Low latency, 2,050 milliseconds. LEO examples: Starlink, SpaceX OneWeb. How does it work? 1. Your dish sends a signal up to a satellite. 2. The satellite relays that signal to a ground station or another satellite. 3. The ground station connects to the internet backbone. 4. The response follows the same path back to your dish. When is satellite used? In remote areas with no wired infrastructure. During natural disasters, for emergency connectivity. 8. Data centers, servers, the brains of the internet. What is a data center? A massive facility filled with racks of servers, which store and process data, run websites, apps, and cloud services. What is a server? A powerful computer designed to provide services like hosting a website or storing files. It's always on, highly redundant, and often virtualized. Why are data centers important? They are the destination of your internet requests. When you watch Netflix, stream Spotify, or access Gmail, you're interacting with a server in a data center. Where are they located? Often near cheap electricity, cold climates for cooling, and major internet hubs. Examples: Google's data center in Oregon, Facebook's in Sweden. Routers, IP addresses DNS, the traffic management system. What is a router? A router directs your data to the correct destination like a GPS for data. It connects your device to the internet. It reads the packet's IP address and determines the best path. What is an IP address? A unique identifier for every device or website on the internet, like a phone number for computers. Example: 142.250.72.46 for Google. Devices use these to send and receive data. What is DNS, domain name system? You type openai.com, not an IP. DNS converts that domain into the correct IP. It's like a phone book for the internet. There are DNS servers worldwide that resolve domains in milliseconds. 10. Summary analogy. The postal system of the digital world: devices, homes, data letters, network, cable roads, routers, post offices, IP, address, mailing address, DNS, phone book, data centers, factories or offices, submarine cables, international shipping routes, satellites, airmail. The internet is like a global, high-speed, automated postal system, moving billions of data letters every second with astonishing precision. That concludes the deep dive. Each layer builds upon the other, from the copper in your wall to the transoceanic cables deep below the sea, all to let you watch a video or send a message in a fraction of a second.
Thanks for watching. I really appreciate you taking the time to check out my video. If you enjoyed it, don't forget to like, comment, and subscribe for more content. Your support means the world to me and helps the channel grow. Stay tuned for more videos, and let me know in the comments what you'd like to see next. See you in the next one.